Hello students, in this video we will add, subtract, and graph polynomials. Well, first let's start by just investigating a polynomial, and in this example we're going to name the coefficient of each term. Now as we look at this polynomial, there are four terms. The terms are those things that are separated by your plus and minus symbols. So we've got a term called 2x to the fourth, and a term called negative x to the third, a term called 1/2 x squared, and a term called 10. Now as we talk about the coefficients in each term, the coefficients are the number part in each term. So our term 2x to the fourth has a coefficient of 2. Our term negative x to the third has a coefficient -1. Okay, you can envision a -1 in front of that x to the third. Okay, our next term 1/2 x squared has a coefficient of 1/2. And our last term is a number only, so you might say it's a coefficient term unto itself, and that is +10. Remember to take your signs with the coefficients. For example, with this second term, that coefficient is -1, not just 1. Now one thing that we're going to do as we add and subtract these polynomials is we're going to combine like terms. And like terms have the same variable or variables raised to the same exponent. So when we consider the expression r squared plus 3r plus 5r squared minus r plus 2, our like terms are r squared and 5r squared. And if we combine those, we combine the coefficients. 1 plus 5 is 6. So we've got 6r squared. We've got another set of like terms in the 3r and the minus r. Combining coefficients, 3 minus 1 is 2, so that's a plus 2r. And then we've got a number only term here at the back. So combining like terms, we combine the coefficients. A polynomial in X is a term or the sum of a finite number of terms of the form ax to the n for any real number a and any whole number n. Some examples of polynomials and their classifications. We might look at a single-termed polynomial like 3x to the fourth. And we say that this is a monomial, mono meaning one. Okay, a monomial, and we might also describe its degree and say that it's a monomial of degree 4. And the degree has everything to do with the exponent. Okay, so this 4 here in the exponent is what we're talking about when we mention degree. Another example, we might write 2x squared plus 10, and this is a two-termed polynomial, isn't it? Or we might say that it is a binomial. And this is a binomial of degree 2. Okay, now there are two terms. We say that this term with the 10 only is of degree 0. We could write it as 10 times x to the 0 power. X to the 0 is 1, okay? And we've also got a term up front, 2x squared. And anytime we're talking about the degree of a polynomial, we look at each term and we find the degree with the term with the highest degree, and we describe that as the degree of the entire polynomial. If we look at a three-termed polynomial, say 1/2 x squared minus x plus 7. This is three terms, or we might call it a trinomial. Okay, so there's our monomial, there's our binomial, here comes our trinomial. And okay, what is its degree? Okay, compare your terms. We've got a 7, that's degree 0. We see a degree 1 term, and we see a degree 2 term, and that's the highest degree, isn't it? So this is a trinomial of degree 2. And as we add more and more terms to our polynomials, we really don't have names for those. But a single-term monomial, two-termed binomial, and a three-termed trinomial are pretty common kinds of polynomials. Well, what are some things that are not polynomials? If you've got any kind of expression that has a square root of x and maybe a plus 2, that's not a polynomial. Or if you see your variable in the denominator, that is not a polynomial. Remember, we would write that as x to the negative 1, wouldn't we? And notice that your exponent there is not a whole number, so it breaks that rule. Another thing that's not a polynomial, any kind of expression that has x raised to a fractional exponent, like x to the 2/3 minus 7x plus 4. That's not a polynomial because we've got an exponent there. Again, that's not a whole number, so that's really the kicker that identifies polynomials. In example 3, we're going to find the value of 2y to the 3rd minus y squared plus 3 for y equal negative 2. So we're simply going to substitute negative 2 for y into this expression and evaluate. So this becomes a 2 times negative 2 to the 3rd minus negative 2 squared plus 3. Negative 2 to the 3rd is negative 8. Negative 2 squared is 4. 2 times negative 8 is negative 16. Minus 4 plus 3. Negative 16 minus 4 is a negative 20. Plus 3 is negative 17. In example 4, we're going to add these polynomials. 4x to the 3rd minus 3x squared plus 2x. So we're going to add that to 6x to the 3rd plus 2x squared minus 3x. And when we add polynomials, we combine like terms. Like terms have the same variables raised to the same exponents. So 4x to the 3rd and 6x to the 3rd are like terms, and they combine to 10x to the 3rd. Okay, that's not 10x to the 6th, it's 10x to the 3rd. Negative 3x squared plus 2x squared combines to a negative 1x squared, or we can just write minus x squared. And we've got 2x minus 3x, which combine to a minus x, and stop. We've combined our like terms. There are no more like terms to combine. It is common to write your answer in decreasing degree order. So it's common to write the 10x to the 3rd term first, the minus x squared term next, and the minus x term last. In example 5, we're going to subtract polynomials. This is just like addition. But be careful and make sure you distribute your minus symbol to each of the terms of the polynomial that we're subtracting. So let's go ahead and take a step and rewrite this as 7y squared plus 11y plus 8 minus the negative is plus 3y squared minus 4y and minus 6. So do go ahead and take that step and write it out, and now we'll combine like terms. 7y squared plus 3y squared is 10y squared. 11y minus 4y is 7y. And 8 minus 6 is 2. Stop there. There are no more like terms to combine. Now, the last thing we're going to do in this section is we're going to graph some polynomials. And our first one we're going to take a look at is y equal x squared. So notice here, okay, this is an equation with two variables, isn't it? And when we see an equation with two variables, we can graph it in a two-dimensional space. And what are the ways that we graph these polynomial type equations? Polynomial, because we're going to see x's raised to whole number powers. Okay, that's why it kind of fits in this section. I'm just going to use a t-table and generate some points by substituting some values for x, like -3, -2, -1, 0, 1, 2, and 3, and just generating some values for y. I like to start right here in the middle with 0, okay? If x is 0, then y is 0 squared, or 0, isn't it? So we've generated a point, x equals 0, y equals 0, and that's right here at the origin. If x is 1, then y is 1 squared, or 1. So we've generated a point, 1, 1. If x is 2, y is 2 squared, or 4. And there's the ordered pair, okay, which plots as the point 2, 4. If x is 3, y is 3 squared, or 9. And there we see the ordered pair 3, 9. So 3 on the x-axis, up 9 units on the y-axis. Okay, so this horizontal axis is our x-axis. That vertical is our y-axis. So if we connect these points with a smooth curve, we see a nice curve over here to the right that's increasing, and we could continue to plot points, but that's enough. Let's choose some negative values like -1. Well, -1 squared, okay, that's -1 times -1, or +1, isn't it? So we've generated the point -1, 1. If x is -2, y is -2 quantity squared, or 4. That generates the ordered pair. I'm going to plot that as the point, -2, 4. And lastly, if x is -3, -3 squared is +9. That generates an ordered pair, -3, 9. And we see some symmetry in this graph, which is called a parabola, actually. Notice that it looks the same on the right side of the y-axis as it does on the left. We say it's symmetrical about the y-axis. So that's your most basic of graphs of parabolas, y equal x squared. We call this a polynomial type equation. In our next example, part B, which we're going to graph as well, we see an x squared, but it's got a negative symbol in front, doesn't it? Along with another term, +1. And I'm going to do the same thing here and just plot some points and generate a graph. And we might choose the same x values, -3, -2, -1, 0, 1, 2, and 3 if we need it. But we know that essentially anytime you see an x squared, we're dealing with a parabola that's going to take some form of this shape. Now it might get moved around, or in this case flipped upside down in our graph. But there's our basic shape that we want to have in our mind when we're graphing anything of the form y equal x squared. Okay. Again, I'm going to start with 0. Substituting 0 for x. That's the negative of 0 squared plus 1. 0 squared is 0, change the sign, it's 0, plus 1 is 1. So we've generated the point 0, 1. The negative of 1 squared plus 1, just be careful here with your signs, okay? That's a 1 squared, or 1. Change the sign to negative. Negative 1 plus 1 is 0, generating the ordered pair 1, 0. the negative of 2 squared plus 1. That's the negative of 4 plus 1, or negative 3. 2 negative 3. The negative of 3 squared plus 1. Okay, 3 squared is 9. Change the sign to negative. Negative 9 plus 1 is negative 8. This is the ordered pair 3, negative 8. And I think I'll plot these points now. We've got 0, 1, 1, 0, 2, negative 3, and 3, negative 8. And so we see that this parabola is opening downward, isn't it? I got this. Connect them with a smooth curve. Okay. Now let's complete the left side, and we know there's going to be some symmetry involved here. So I think I know what's going to happen over there, right? The opposite of negative 1 squared plus 1. Okay. Negative 1 squared is 1. Change the sign to negative 1. Plus 1 is 0. Negative 1, 0. And that sort of matches the point we found below, doesn't it? Negative 1, 0. The opposite of negative 2 squared plus 1. Okay, that's the opposite of 4 plus 1, or negative 3. Let's wrap this up, okay? Negative 2, negative 3, and there's our sister point there. And I'm pretty sure I know what's going to happen. If we substitute negative 3, we're going to get a negative 8 there. Okay, plot our last 2 points. Negative 2, negative 3, and negative 3, negative 8. And we see that symmetry involved. Connect those points with a nice smooth curve, and notice that this is a parabola that opens downward, doesn't it? Okay, it opens downward because of that negative symbol in front of the x squared. And the point, or we say the vertex of this parabola, got shifted up 1 unit from the origin because of this plus 1. All right, students, good luck with these, adding and subtracting polynomials and graphing some basic polynomials.